Inverter.
Welcome to ClickMyProject.com. The title of the project is Parkinson's Disease Prediction Using Machine Learning and Deep Learning Algorithm. The abstract of the project is Parkinson's disease is a Parkinson's disease is a serious neurodegenerative disorder. It is reported that most of Parkinson's disease patients have voice impairments. Accurately detecting Parkinson's disease at an early stage is certainly indispensable for slowing down its progress and providing patients the possibility of accessing to disease-modifying therapy. Towards this end, the premotor stage in Parkinson's disease should be carefully monitored. An innovative deep learning technique is introduced to early uncover whether an individual is affected with this Parkinson's disease or not based on premotor features. In this process, the machine learning algorithms and deep learning algorithms are applied and classify the Parkinson's disease. In this method based on relatively small data including healthy individuals and early Parkinson's disease patients shows the superior detection performance of the designed model which achieves the highest accuracy and also detects the precision, recall, F1 score, sensitivity and specificity of the flow diagram of the project is the input dataset is a Parkinson's disease dataset. Then the dataset is applied into data pre-processing method. In data pre-processing, it will find the handling the missing data. If it is any data is missing in the dataset, it will replace the datasets in unique value and it will apply into the feature selection model. In feature selection model, the dataset is split into training and testing dataset. That training dataset contains 80% and testing dataset contains 20% of data. And then it will apply into the classification method. In classification method, various machine learning algorithm and deep learning algorithm is applied to predict the Parkinson's disease. The classification algorithms are support vector machine algorithm, decision tree machine learning algorithm, logistic regression machine learning algorithm, and artificial neural network deep learning algorithm. And the final performance is based on accuracy, precision, recall, F1 score, specificity, and sensitivity. It's based on the Parkinson disease. I'm going to run my project in Anaconda Navigator Spider IDE. This is a sample dataset of Parkinson disease. XGBoost training accuracy is 100, XGBoost precision training is 100, recall is 100 and sensitivity is 100. Testing result is 94 and precision is 96 and recall is 96 and specificity is 85 and sensitivity is 85. And then support vector mission accuracy, training accuracy is 87%, precision is 87, recall value is 96 and specificity value is 86 and sensitivity value is 86. And testing result of SPM accuracy is 89 and testing precision is 91 and testing recall is 96 and testing specificity is 80 and testing sensitivity is 80. And decision tree algorithm. In decision tree algorithm, training accuracy is 100 and training precision is 100, training recall is 100, training specificity is 100, training sensitivity is 100. Testing result of testing accuracy of decision tree is 89, testing precision is 91, testing recall is 92, testing specificity is 80, testing sensitivity is 80. Then logistic regression algorithm. Logistic regression algorithm training accuracy is 84, training precision is 86, training recall is 93, and training specificity is 77, and training sensitivity is 77. And the logistic regression testing accuracy is 89, testing precision is 91, testing recall is 96, and specificity Testing specificity is also 80 and testing sensitivity is also 80. And artificial neural network deep learning algorithm. In deep learning algorithm, training accuracy is 43%, score is 43%, training accuracy is 85%, and testing score is 35%, and testing accuracy is 87%. This is the heat map diagram of our data set. This is Parkinson disease present, and this is Parkinson disease not present, based on our target value. This is our original data set. These are all predicted classes. X value of our data set, X test value of our data set, X train value of our data set, Y value of our data set, Y prediction value of our data set. Predictor is based on disease or not. If the true is disease is present, false means disease is not present. This is Y test value. This is Y train value.